Welcome to the Level 2 video on binomial expansion and Taylor's series. Today we're going to start off by talking about some Taylor series. And let's start off by saying the following. The Taylor series of a real or complex valued function, say f of x, that is infinitely differentiable at a real or complex number, say A, is the power series f evaluated at A plus the first derivative evaluated at A divided by 1 factorial multiplied by x minus A plus the second derivative of f evaluated at A divided by 2 factorial multiplied by x minus A squared plus the third derivative of f evaluated at A divided by 3 factorial multiplied by x minus A cubed, so on and so on. Or alternatively, this can be written as a summation, n starting at 0 all the way to infinity of the nth derivative of f evaluated at A divided by n factorial multiplied by x minus A to the power of n. A quick example of a Taylor series question: determine the first 5 terms of the Taylor series for the following function. And the function is f of x equals cos of 4x, and we want to expand around x is 0. So our solution is, let's define what f of x and its derivatives is at x equals 0. So f of 0, cos of 0 is of course 1, and the derivative of f at 0 is minus 4 sine 4 of x evaluated at 0 is of course 0 because sine of 0 is 0. F double dash of 0 is minus 16 cos of 4x evaluated at 0 gives us minus 16, and then the third derivative evaluated at 0 we get 64 sine of 4x evaluated at x equals 0, which is 0. And we can see a general pattern here. So the even derivatives of f evaluated at 0 are going to be minus 1 to the power of n multiplied by 4 to the power of 2n, and all of the odd derivatives are going to vanish and be 0. So the Taylor expansion of cos of 4x is going to be 1 minus 16 over 2 factorial x squared plus 16 squared over 4 factorial x to the 4 plus 16 cubed divided by 6 factorial times x to the 6 plus 16 to the 4 divided by 8 factorial multiplied by x to the 8, and they're just the first 5 terms, so we stop there. And simplifying all of these factorials, we'll get that the Taylor expansion is 1 minus 8x squared plus 32 over 3 x to the 4 plus 256 over 45 x to the 6 plus 512 over 315 x to the 8. And these are the first 5 terms in the Taylor expansion, so we're done. And another quick example. Again, determine the first 5 terms of the Taylor series for the following function. And the function is f of x equals x times e to the 2x, and let's do that around x equals 0 again. And our solution to this is, again, let's evaluate f of x and its derivatives at x equals 0. So f of 0 is going to, of course, be 0. And the first derivative of f at the point 0 is going to be 2x e to the 2x plus e to the 2x. Evaluated at x equals 0 gives us 1. And the second derivative of f evaluated at 0 gives us 2e to the 2x plus 2e to the 2x plus 4x e to the 2x. This evaluated at 0 gives us 4, because there we've actually got 4e to the 2x. And then the third derivative of f evaluated at 0, we get 8 e to the 2x plus 8x e to the 2x plus 4 e to the 2x. And let's simplify that to 12e to the 2x plus 8x e to the 2x, and evaluate at 0, and that gives us 12. And then finally, the fourth derivative of f evaluated at 0 gives us 24 e to the 2x plus 16 x e to the 2x plus 8 e to the 2x evaluated at 0. And let's simplify this to 32 e to the 2x plus 16 x e to the 2x, and evaluate this at x equals 0 to get 32. Then we can see the pattern, and we can see that the fifth derivative of f at x0 is going to be 80, as it's 2 times 32 plus 16. So we know that the Taylor expansion is going to be 1 over 1 factorial times x plus 4 over 2 factorial times x squared plus 12 over 3 factorial times x cubed plus 32 over 4 factorial times x to the 4 plus 80 over 5 factorial times x to the 5, and that's all we need. Simplifying these factorials, we get x plus 2x squared plus 2x cubed plus 4/3 x to the 4 plus 2/3 x to the 5, and those are our first 5 terms. Thanks very much for listening.